All right, hello everybody. This is the review for our Unit 3-1 and -2 test. I thought I would be a little bit funny, at least try to be a little bit funny, and start out the review with a joke. I found this online. And since we are playing with our trig ratios, I thought this would be pretty funny and appropriate. So what do you call a man who spent all summer at the beach? A tangent. Haha, super funny, right? All right, let's go ahead and get started with our review. I will go as fast as I can through this. You can always stop, pause it, and rewind me if you need to. All right, first question. While traveling across flat land, you notice an oil derrick from ground level. The angle of elevation to the top is 35 degrees. After walking 50 feet closer to the oil derrick, the angle of elevation changes to 40 degrees. Find the appropriate height for the tower round to the nearest tenth. All right, so a couple things that I want to do is take this picture and send it to the back because I've kind of labeled some things. So once I send that into the back, we can look at our labels. And from the word problem, I know that this angle here is 35 degrees. And this angle here is 40 degrees, and the distance from this point to this point is 50 feet. Okay, because of supplementary angles, I know that this angle is 140 degrees, and because all three angles add up to 180, I know that this is 5 degrees, because if I have 140 plus 35, I get 175. 180 minus 175 gives me 5 degrees. So I know all my angles, and I know this side. I'm going to set up my law of sines ratios. So I have 50 over sine of 5, and that's going to equal b, which is this side here, over sine of 35, since 35 is directly opposite. I cross multiply and divide, and I find that b is going to equal 329.053. And so now I know that this is going to be a right triangle because it's flat land, and I'm assuming that the tower is straight up and down, completely vertical. So I have this angle. I'm looking for my opposite side, and I now know my hypotenuse. So I can set up my trig ratio for sine. So because my angle is 40, I have the sine of 40 will equal the ratio of side C divided by side B, and I know that side B is 329.053. So I'm going to multiply both sides by this number, and C ends up by itself. Multiply it out, plug it into the calculator, and I get side C is 211.51 feet. Okay. So there's problem number 1. Let's move on. Number 2, the second hand on the clock is 5 inches long. Approximately how far does a tip travel in 3 minutes and 15 seconds? So for 3 minutes, it's going to start here, and it's going to go around once, twice, 3 times, and then it's going to go another 90 degrees. So if I'm adding all my angles, my degrees together, I have 3 revolutions, and there's 360 degrees in one revolution, so 3 times 360 plus the extra 90 degrees will give me 1,170 degrees. I need to convert that into radians before I can find the arc length. This is the arc length formula, my radians times my radius. So I convert it into radians, and notice I'm not simplifying this, I'm plugging it all into my calculator, and I calculate everything out, and I get 102.1 inches. Alright, next problem. The latitude of San Antonio, Texas is 29.5 degrees, and so that's latitude always starts at the origin and goes up. So this angle here is 29.5. Mexico City has a latitude of 20 degrees, so from here to here is 20. and I want to know what is the distance from here to here. So in order to find this angle here, I'm going to take 29.5 and subtract by 20. That gives me my angle of 9.5, and then 9.5 degrees, and then I need to convert it into radians in order to find arc length. Again, this is another arc length problem, but this time my radius is 4,000. I multiply everything out. I get 663.2 miles. Okay, it'll end up being miles. All right, next problem. Find the area of a sector if the central angle of the circle measures 64 degrees and has a radius of 8 centimeters. The formula to find the area is 1/2 my theta, which is in radians, times my radius squared. So I get 64 multiplied by pi divided by 180, changes it into radians, times my radius, which is 8 centimeters squared, times 1/2. Plug everything in, and I get 35.7 centimeters squared. That's right there. Okay. Problem 5. Given a triangle with a measure of angle A, it equals 72, side A is 3, and side B is 21. Find the number of possible solutions for angle B. All right, so notice I just labeled these. It doesn't matter how you label it as long as angle A is directly opposite of side A, angle B is directly opposite of B, and angle C is directly opposite of C. So I went ahead and labeled those, and then I substituted my numbers. Angle A is 72 degrees, side B is 21, and side A is 3. Okay, we want to find side B. So I set up my law of sine ratios. I get 3 over sine 72 equals 21 over sine B. I cross multiply and divide. I get sine B on its own. Everything else is on the other side of the equal sign. I'm looking for B, so I'm going to switch the locations of this and this. So I'm doing inverse sine of this ratio will equal my B. When I plug it into the calculator, I get undefined. Okay, so for this situation, I have no solution. Okay, there's no possible way to make a triangle with those angles in degrees. Okay. But what if, instead of getting the term undefined, let's say I got 30 degrees for B? Well, then I know that I can have one possible triangle. So I could have one solution, but I may have two different solutions. So to see if I can possibly have another solution, I'm going to take 180 degrees minus my B value, my angle that I had found for angle B, which is 30, and I get an alternative angle for angle B of 150 degrees. Well, the only way this can be an alternative is if I add angle B and angle A together, subtract it from 180, and I would have to get a positive angle here. Okay? So notice I'm getting a negative angle, so that means that if my answer was 30, now in this case it wasn't, it was undefined, but remember you're going to have 4 different versions of the test. You might have one of the versions where you'll only have one right answer, you might have 2 right answers, or you might have no solution, or it may be impossible to determine. I will tell you, most of you can just pitch this option out. So if for any reason on your final answer up here you did all the math and realize I am changing the numbers, but you plug everything in correctly and you get 30 degrees and you take that away from 180 and you end up with a negative number. Okay, that means that you cannot have the alternative angle, so you only have one solution. But let's say you did all this math and you got the number 85. Well, and to check to see if another possible option is available, you do 180 minus 85, you get 95 for the alternative. This would be the alternative angle B. Okay, so you want to add angle A and your alternative angle B together, subtract them from 180, and in that case, you do get a positive number for the third angle. So for this one, if this was your situation, you would only have one possible solution. If this was your situation, you'd have two possible solutions. If you get undefined, then you have zero possible solutions, or there's no possible solutions. Okay. This one, number 6, very similar to a word problem that one of the groups had a couple of weeks ago. You have in baseball, the distance between the pitcher's mound and home plate is 60.5 feet. You've got a 45-degree angle here, and the distance from home to first base is 90 feet. And you are looking for this distance. Let's call that side A. Okay, if you're looking for side A and you know side and angle in between and then the other side, then you can use the law of cosines. Now, down here it says use either the law of sines or the law of cosines to solve. The reason why they give you those options is because they do not want you to assume that this is a right angle. It will not always be a right angle right there. So we can't just use our trig ratios. We have to use either law of sine or law of cosine. With this information, I cannot use the law of sines. Okay, I have to use the law of cosine to solve this. Okay, so I set up my ratios. I'm looking for side A, and side A is directly opposite of 45, so I'm going to have A squared over here and 45 on the other end. And then I take my other two sides and square them, add them together, subtract by 2 times one side times the other side times cosine of my angle, which is 45. I plug everything in and get this huge number. Okay, but remember, you've got a square here, so we have to square root everything, and I find that the pitcher has to throw the ball 63.72 feet to first base. Okay, all right, set problem 7 and 8. You've got a pulley turning 60 degrees per second. Find the number of revolutions per minute, just your conversion. So you have 60 degrees. We want to change it to revolutions. There's 360 degrees in one revolution. And then we want to turn seconds into minutes. There's 60 seconds in 1 minute. Let's cross off what we can to make sure we have the correct measurements at the end. We are looking for revolutions per minute. And so we're left with revolutions and we're left with minutes. So that's what we're looking for, but we're not done. We need to go ahead and simplify this, and we end up with 10 revolutions per minute. Okay, now here's number 8. If the radius of a pulley in the previous question is 7 inches, find the linear velocity in inches per second. Now, if you try to use this, you're going to get the wrong answer, okay? So 2 ways you can do this. You can go back to your angle in 60 degrees and convert it to radians by multiplying by pi and divide by 180. Or you can take the 10 revolutions, multiply them by 2 pi because there's 2 pi radians in each revolution. Either way, you multiply that all out. And then this will actually simplify to pi over 3. And then you times it by 7. Let's see. Oops, you know what? You cannot do that because this is in revolutions per minute and they want seconds. So scratch all this. Do not do that. Go back to what you originally had in per second. Okay? Check your units of measurement. Make sure you convert them to the right units. All right, so we have 60 pi over 180 degrees reduces to pi over 3, and then you multiply it by your radius, which is 7, to get the arc length, and you get 7.33, which is this answer. Okay, we are over halfway done, so just hang on, we are almost done. So you have a triangle formed between 3 polygons with adjacent sides of 23, 32, and 15 feet. Sorry for the extra noise. I have people coming in and out. They're leaving now, though. All right. Sorry. So if you look at this triangle, it looks like you might possibly have a right triangle here, but it's not labeled, so we cannot assume that it's right. But we have 3 sides, and we just need to find one of the angles. It does not matter which angle. You can set it up to find angle A, angle B, or angle C as long as you label them and keep the labels coordinated with the opposite sides when you're setting it up. Okay, it does not matter which way you go. Because I have cosine A up here, I'm going to solve for cosine A. To do that, you're going to start here, and you want to get all your numbers on one side of the equal sign. So we have 15 squared. We're going to subtract these two numbers to move them over. And then because we're timesing here, we have to divide by all of these numbers. And then all this ratio will equal cosine A. To get A by itself, you do the inverse cosine. You plug that in, and you get A equals 25.6 degrees. But we're not done. We are actually looking for the area. And because we know that angle A is 25.6 degrees, then we can use this information in my area formula. To use the area, you have to have one side, you have to have two sides and the angle in between them, and you use the sine function. So 1/2 times one side times the other side times sine of my angle in between the two, plug it all in, and you get this answer right here, and that's in feet squared. Okay. Number 10, find the value of x, round the angle measure to the 10th of degrees. So you have the opposite and you have the adjacent. So that's our SOHCAHTOA. Tangent equals the ratio of the opposite over adjacent. So you set it up, tangent x equals opposite over adjacent. We want to find x, so we're going to do inverse tangent of the fraction, and that's going to give us our x value or our degree angles. Okay, problem number 11, 5 more to go, or no, 4 more to go, I don't know. We're almost done, guys. We want to find x this time, and this time x is a side value. Again, we have our angle, we're looking for the opposite side, and we have the adjacent. So we'd have tangent 20 equals x over 8. We're going to multiply both sides by 8 in order to find x, and we get 2.91, which is right there. Okay. This one, you're just converting between degrees and radians and degrees. Super easy, at least it should be. You have 540 degrees, times it by pi, divide by 180. Remember, we do not get rid of our pi when we're converting into radians. We're just reducing that. 54 divided by 18 equals 3, and so we have 3 pi there. Okay. I was super nice with this. I went ahead, and if you included pi in your fraction, I went ahead and put what the rounded answer would be as well. For number 13, convert 5 pi over 12 into radians to degrees. There's two ways you can set it up. You can set it up like this. You take your fraction, multiply by 180, and divide by pi. Or you can set it up like this, where you have two separate fractions. Either one works. In both cases, your pi's cancel each other out, and you're just dealing with the numbers then. And in this case, your answer will be 75 degrees both times. All right, let's see. Oh, we have 2 more. All right, here's another one. We have the arc length here and the radius, and this time we're finding the angle. So it's a little bit opposite of what we've done for most of the problems where we were dealing with the arc length. So your formula for the arc length is the arc length will equal radius times theta. And so our arc length is 12 centimeters, radius is 50 centimeters. To find theta, we divide by 50, and we get theta equals 0.24. But they want to know how many degrees does the pendulum move. So now we need to convert theta, which is in radians, into degrees. We multiply by 180, divide by pi, plug it all into our calculator, and we get 13.8 degrees. Last one. On its axis, the Earth spins once every day. Convert this rate into degrees per minute. So 1 revolution in 1 day. To convert days into minutes, we multiply by 1 day. It has 24 hours. and then multiply that by 1 hour has 60 minutes, and then to convert revolutions into degrees, in 1 revolution we have 360 degrees. Cross out all your units of measurement that you can. Make sure you have the right units of measurement. So we'll have degrees per day, and that's what we were looking for, is degrees per day. Multiply all this, divide it by all this, plug it into your calculator, and you get 0.25 degrees per minute, which seems pretty slow. All right, so that's the end of the review. I hope you enjoy it. Please study it. If you have any questions, ask me in class on Wednesday. Bye.